Great. So Rowan, over to you. What was your motivation for putting this course together?
Well, I mentioned before that I work at London CLC. I work with schools supporting mostly the computing curriculum and mostly primary schools. So my focus is very much on and kind of at the CLC we've all kind of got different interests and skills, but for me the computer science aspect of the computing curriculum is the thing that really fascinates me, and so I spend a lot of time thinking about what are the best ways of kind of like approaching that subject, approaching those ideas, and particularly with younger children, but then also thinking about how that kind of develops as the children get older and as the concepts become more complex. So that's always kind of in the back of my mind, but I also happen to know some through work and some socially, quite a few people that work in the software industry. And I found myself having very similar conversations sort of again and again with some of those people, which include Marius, about some of the kind of frustrations of people working in the software industry, and some of the kind of the challenges to sort of working in a team, and in particular how sometimes that can be made more difficult because of the way that people have kind of learned to approach the subject and some of the ideas in it, and how a part of that I think is just a challenge with the fact that it's an area that is obviously it's changing all the time, and what people are making and how people are making them is always changing and developing. But I think that like having those conversations kind of made me feel that there actually are some kind of like quite fundamental things about the way that you can approach problems and the way that you can think about things and work as part of a team, that I think that they can still apply, like even as the world of programming changes, even if you're using a different programming language, there are certain things that you can do that I think are helpful, and hopefully will help children as they grow up. So it was kind of like for me a process of sort of translating these ideas that were very much like work focused into like how would that be relevant in a primary classroom, and that might seem really different and really far apart, but I'm not sure it is. And we had interesting discussions, and I've tried to kind of take some of what we talked about into my own teaching. So I hope that some of the things that I mentioned might be helpful for you guys as well. I know we've got a mix of primary and secondary, but as I say, I think that these principles are things that are not specific to a programming language, but I've chosen Scratch because it's something that is visual, and it's a kind of a good way in, I think, to a lot of the kind of constructs that you talk about in other languages like Python and things later on.
Great, thank you, Rowan. And to Marius, from the industry perspective, how important do you think it is to get young people working with these good practices from a really early point?
So I think it's really essential, and it kind of goes back to what Rowan says. A vast amount of what we do in the industry in software engineering isn't software engineering. It's all the stuff you do around it. It's how you work in a team. It's how you make the software you work on accessible to other people. And as Rowan said, the particular language isn't really the issue there. And I think the reason it's so important is that kind of way of approaching things is something we often find when we onboard new folk into our organization, but also this is something is common across pretty much every client I work with as well. A lot of the early days of someone in these organizations is being taught this stuff again, to be honest, and having to either learn it for the first time or be reminded of it. And so the more people kind of understand good practice in the most general sense and have those patterns of working and thought there, simply put, the more ready they are to work in industry, but also kind of selfishly from our side, the faster we can get them cracking on stuff and make them, valuable to our businesses, but also, as successful individually as they can be.
So, does anyone have a question that they would like to raise at this point? We'll just do 5 minutes for any initial questions. We'll have some more question time at the end. Great, I guess we'll crack on. I'm sure questions will appear throughout the session. So what I'm going to do now is hand over to Rowan, who is going to run us through kind of a cut down version of what you can find on the site in the Code Like a Pro online course, which I obviously encourage everybody to go and have a look at, and kind of talk us through some of her thinking with that course. Whilst Rowan is talking, if any of you do have a question that comes to you that you would like to sort of put aside for later, I'll be monitoring the chat on Zoom. For anyone who hasn't used Zoom before or anything, the chat function is at the bottom, and you can send a message to the group. So do ping your questions in there. And oh, hello. Excellent. Asking around to explain was my question. That's a winner. And do ping your questions in there, and we'll come to them at the end for our Q&A session. So Rowan, over to you and your screen share.
Cool. Okay. Can you all see that?
Yes.
Okay. Yeah. So as Caitlin mentioned, what I'm going to show you is kind of it's basically part of an online course that I wrote halfway. So I think it's 3 out of 5 of the kind of headings that are in there. So if you're interested and you want to learn a little bit more, there's more on the website. But it's fairly short. It's not like hugely lengthy. So it might be, you know, a nice little bit of professional development to do in these slightly strange times. Yeah, so obviously I think we can probably all agree, hopefully particularly as people that are teaching computing, but also as people that are probably using technology quite a lot at the moment, we can probably all agree that using and understanding technology and software is a really important set of skills to have in this time in history. And so something that I spend a lot of time thinking about is whether or not whether we're teaching children to do that in a way which sort of supports them in the future. And in particular, whether we're teaching them to create code which is of high quality. And that's kind of a difficult question, because obviously in order to judge that, you have to know what makes high quality code. And that's not that easy to answer. It's something that a lot of industry professionals have debates about. There are lots of different ways that you can approach it. But when you're learning to program, especially in kind of quite informal environments, we're often told that there are lots and lots of different solutions to any given problem. There are loads of different ways you can solve a problem, and that as long as your solution achieves the desired outcome, it's just as good as anybody else's. But I think something that Marius and I spent quite a long time talking about when we started to put this course together was that actually that's not necessarily true, particularly if you are working as part of a team. And actually, if you are a software developer, you pretty much definitely are working as part of a team. So you're not working in isolation on a discrete problem. It's not usually the case that there's just one little thing that needs to be solved that's separate from everything else, and that if you solve it, then you've done your bit. It's more likely to be that the solution that you're working on is part of a really complicated network of other problems that other people are working on, and each person has a different role and different skills and different knowledge. So in order for that to work effectively, everybody needs to be able to kind of understand their part in that process, and needs to be able to communicate their ideas between each other. So they need to find solutions to problems that can be adapted and can be improved and grown and changed as problems change. So I know that sounds quite sort of like high level, and it's very much career focused, and the Tech Pathways training is it's about kind of linking what children learn at school with future careers. But I actually think that these sets of ideas, if we kind of pick them up earlier and we start to use them a little bit earlier on, that they can be really helpful for when we kind of learn more as we go through our programming careers. So I've kind of come up with a few little kind of approaches, a few ways of thinking about things that I think, or I hope might be able to help with that. So as I said, if you're interested in learning a bit more, that's the link to the Tech Pathways website that Caitlin showed us. So it contains a little bit about efficiency and adaptability, and a little bit about testing as well, the full course. But in this section, the first bit that I will talk about is methods and procedures in programming. So those of you who are in secondary, this will probably already be quite familiar. But it's not in the computing curriculum in primary, which I always find I can kind of understand why, but I actually think that learning about methods and procedures early on is quite helpful. And so apologies if that's a kind of new term that you're not familiar with. I'll show you an example of what methods and procedures are, and hopefully it will make a little bit more sense. So in Scratch, if you're, well, actually, just more generally, if you're collaborating with a colleague on any piece of work, it might be programming, or you might be writing a piece of text together. It's obviously really important that when you make a contribution, that it's kind of like named and labelled in a way where it's quite clear to see who has done what and what each section is, particularly if it's something quite complicated. And so this applies just as much to code as it would to any natural language. But often quite a common habit that you see, particularly among really enthusiastic programmers, actually, what I find like it's often the children that are really keen on programming with Scratch and that want to learn more and want to push themselves, will also be the children that like to make really, really long, really complicated scripts, but when you try and look through them and read them, they make no sense. And it's always like impossible to understand what they're doing. And even if the script works, for them to actually be able to explain it is really difficult, because they've kind of created a problem or created a solution which is presented in a way that's quite hard to understand. So obviously it can be quite fun to challenge ourselves in this kind of way, where we make things like look complicated. But if we want to work with other people, or if we want our teacher to feed back on the work that we've produced, then it's going to be important to present our work in a way that's easier to understand. So in Scratch, the blocks you can see on the screen at the moment, these pink blocks, they're in the My Blocks section of Scratch. And in that section, you can basically build your own blocks and you can get them to do different things. So I'll show you an example of that in a second. But this is a Scratch project which you can see compared on the screen at the moment. On the left is what this project is supposed to do, and on the right is what it does at the moment. So this is a drawing project where I've programmed the sprite, which is a pencil, to move around the screen and to make different like shapes and patterns. And in Scratch there are some blocks called the pen blocks, and the pen blocks you basically use to tell your character to draw a dot or a blob, and you can control the size of the blob and you can control the color and a few other things as well. So this program is built using those blocks. But when we click see inside on the project so that we can actually have a look at how it's been programmed, you can see what the code looks like. And it's pretty confusing. So it's all in one long list. And basically this is a list of blocks that gets the sprite to do what you saw on this page. So it gets it to draw the sky and the sun and the sand dunes, and then it gets to draw a tree, and then it does all of the leaves of the tree. And each of those instructions happens one after the other in this big long list. But at the moment, it's really hard to work out which bit of code is responsible for which part of that picture, because it's just all stuck together. And you could work it out by looking at things like color and maybe number of repetitions, but it would be pretty difficult and pretty confusing. So if we want to try and solve the problem of working out why this tree is being drawn sideways and why it's sort of fallen over, it's going to be very hard to do it if we've programmed it in this way. But if you have a look at this version of the project, so this is basically exactly the same project. It uses all of the same commands. So the pen is following the same set of instructions. It does basically the same thing. But the parts of the code that create each different bit of the picture that I described just now, they're all named. They're kind of like broken up into chunks, and then I've given them a name. So you can see if you have a look at the blocks that, for example, there is a set of blocks that draws the sun. And if you look at the pink block that says define sun, then underneath it you can see how the sun is drawn in this project. And that's true for each little chunk of the picture. So when we look at it like this, then maybe it might be easier to identify where the problem was in the way that the trunk is drawn. We know the trunk is coming up sideways and it's going that way. So if we look at the blocks in the trunk section, we can see that one of them is the direction block. And the direction block is the one that's responsible for which way the pen is facing when it draws. And at the moment it says 90 degrees. So if you've used Scratch before, then you might know that that the direction block, it basically works like if you imagine a clock face with 0 at the top. If you set the direction to 0, then it will be pointing up. If you set it to 180, it will be pointing down. So 90 is at like 3 o'clock. So it means it's kind of 90 degrees away from the up position. And that can help us to fix the problem. So, so you can see if you change the number 90 to a number 0, then instead of pointing to the right, then your pencil is going to be pointing upward in order to draw the picture. And that's a kind of easy, simple way of fixing that problem. It would have been really hard to find that very specific block in that big long list of instructions we saw before and to change it to the right number. But now that it's broken up into chunks, it's a little bit easier to see. So the more blocks function is a really great way to teach children the importance of breaking down complex problems into smaller, more manageable parts. And that's an essential skill for anyone that's working in software. And it also makes code like more comprehensible. It reduces the duplication that you might need to use in your code as well, because it means that you have a way, if you work out how to solve a problem, but you need that solution multiple times, you've got your own block that you can reuse. For example, in this picture, if I wanted to have not just one tree, but 3 trees, all I would need to do is take those blocks, the trunk, the big leaves and the little leaves, and I could reuse them so that I can repeat that process. And then that also means that if there was something wrong with that process, I would only need to fix it once. I wouldn't have to go through each tree and repair the problem. I could just go to my, maybe my trunk block or maybe my leaves blocks, and I could fix it like that. So, but importantly for computer science, the MyBlocks tool is a useful tool for helping children to develop their sort of sense of abstraction and decomposition in programming. So it helps you understand the project at different levels of detail, at the appropriate level of detail for what you're trying to do to the project. So somebody asked me, how does the palm tree project create its picture? What I could do is just look at the green flag block, and then I could just read out the pink blocks underneath it. So I could say, well, when you click the green flag, it resets everything, and then it draws the sky, then the sun, then the sand dunes, then the trunk, then the big leaves, the little leaves, and then it disappears, it hides. So that's a kind of like quite high level, not too much detail way of thinking about this project. But then if you ask me exactly how one part of it was programmed, then I could say, oh, well, the sand dunes, for example, have been programmed in this way by looking at the specific blocks that are attached to that pink define block. So in programming terms, you can really justify using a procedure whenever you find yourself using the same sequence of blocks multiple times, or whenever you find yourself making a list of blocks that is getting a bit too long, a bit too complicated. And it's kind of hard to judge when that is necessary. And I suppose it's sort of, some of it just comes down to sort of like something feeling like a sort of complete process, really. But there's a website called Quality for Blocks, which was a research project by Virginia Tech, and that talks a lot about kind of how to define code quality specifically in Scratch. And that actually suggests that you shouldn't really have any more than about 11 blocks in one vertical list, which when I look back over my projects, I have not always followed that rule. But I think it's interesting to think about kind of at what point things start to get a bit too long and a bit too confusing and too complicated. So the second kind of approach to kind of introducing this idea of quality in programming with Scratch is really just about like keeping things tidy. It's just about naming and organizing things, really. So in the last activity, it was quite confusing when the assets, and when I say assets, I'm talking about the sprites or characters, their costumes, the sounds, when each of those things is not named in a way that makes it easy to identify them. So the team that developed Scratch have actually tried to make that a little bit easier to do, because it used to be that anytime you added a new character in, it would always just call it Sprite 1, Sprite 2, Sprite 3, Sprite 4, which makes it quite hard to distinguish between them when they're mentioned in your code. And it now does a thing where, like, if you add a character that's a cat from the library of pictures, it will name it cat, or if you add a dog, it will name it dog. So it's a bit easier to sort of tell everything apart and to keep things organized. And actually that particular feature hadn't been introduced yet when I made the project that I'm going to show you now, which is, so this is a project I made quite a long time ago in Scratch. It was like when I was sort of like exploring and starting to learn to use Scratch a little bit, this was one of the things that I made. I think it actually didn't start from the beginning there, but basically it's a maze game with a monkey. And you can see that the monkey goes through the maze and collects up these bananas. So just having a little bit of a look at it, you can start to think of all of the different assets that are involved in this project. So you've got the monkey itself, And then you've got the parrot that's right there, but the parrot, it flaps its wings, so it's one character, but it's actually got two costumes because it kind of moves. There's all the bananas, there's this octopus as well. So there's quite a few different like objects in the project that I've had to kind of make and use in my program in order to make it work. And when I did that, I actually did it in a way that was very disorganized and confusing and quite messy. And it meant that whenever I had a problem, if something went wrong when I was trying to develop the project, it was really hard to work out how to fix it. So this is when I've pressed C inside so that you can see all my code. And right now, there are loads of different scripts, but we're actually only looking at the monkey's the code for the monkey. And you can see if you have a look on the right-hand side, there are loads of other characters. The monkey has most code in this project, but the other characters have their own as well. So you can see it's a pretty kind of confusing and complicated world, which has been programmed in a way that's not very easy to understand. So there's a few problems with it really. One of them is that if you look at the names of the sprites, they're called like sprite 1 and sprite 2 and sprite 3, etc. like I mentioned before. And that means that if I want to program like the monkey to do something when it touches the parrot, for example, I have to be able to remember that the parrot is called sprite 2. It's not very easy to remember when you're reading the code back, because it's like, which sprite was sprite 2? Was it the banana or was it the parrot, and so on. And then as well as that, if you look at the structure of the program, of the code itself and the way the blocks have been put together, there's quite a lot of like loops within loops within loops, which can be a bit confusing to try to make sense of when you're reading them. So when I made this project, I had a reasonable sense of like how to make things happen in Scratch, how to solve problems, the practicalities of like getting things done. But I hadn't really thought that much about the ways of organizing things, the approaches that I could use, particularly if I were working in a team. I made this game just as a little thing to do on my own as a fun, I was on a train actually, a thing to keep myself busy. I wasn't working with someone else. I didn't have to explain anything that I did to make sense to them. And very few people do learn to program with those sorts of factors in mind. But if we learn them a bit earlier on, then it can make collaboration a little bit easier as we get older and as we start to approach more complicated challenges. So this is the second version of the same project. And like with the previous ones, it does essentially, it does the same thing. It's a maze game, and it's the same monkey, and he follows the same path. But you can see I've organized it a little bit better in this version. So you can see like I've changed the names of the characters and things like that. I've like slightly tidied up the code, but there is still quite a lot of confusing and inefficient things going on in this project. So the fact that like when you look at the monkey scripts, you can see that there is sort of very, very similar, actually the same patterns of blocks appearing in lots of different places. So like I mentioned before, that probably means I could bundle up some of these blocks and I could create a procedure, and I could then call on that procedure in multiple places so that I don't have to keep on using the same series of blocks again and again and again in a way that can be quite complicated. So that's what I've done in this final version of the project. So you can see it's a lot easier to read what's going on in this project. This code does the same job as the previous code, and obviously there's less of it, which is, I suppose, sort of helpful, but it's also just helpful that you can read it more easily and you can kind of understand it. I've added in things like the OR operator, which is a light green block, so that instead of having a separate script that makes the walls solid on each level, I've got one script that makes the walls work whether they're blue, purple, or pink, and so on. So there's a few different things I've done just to kind of make the code itself like more adaptable and versatile. And there are probably lots of other things that I could have done as well. So that's not like an exhaustive list of like how you can optimize programming in Scratch, but it's just a sort of like selection of kind of how you might look at something and think, well, actually, if we tidy this up, what would we do that would make it easier to use and easier to understand? And if you have any suggestions, by the way, if you want to have a look at the project and make any comments, it's on my Scratch profile, which you can see at the bottom of this page, which is R.A. Roberts. And I post quite a lot of like projects with explanations in them for how you might use them with kids on my Scratch account. So feel free to have a little look and to comment if you have any thoughts. And speaking of commenting, the last little section is about using commenting, but commenting within programming itself. So I guess the other things I've kind of shown so far have been talking about making code easier to understand, and more in terms of how the code is structured and how it's organized. But another really simple, more direct way of doing that is just to explain it in the code, to use comments to say what it does and what it's for. And you can do, this is something that you can do in Scratch with these kind of little sticky notes. So if you right click on a block, you can attach a comment, and then you can use it. There's lots of different reasons that you might use it. So as a teacher, you might use it to ask your pupils to demonstrate their understanding. They might annotate their own code to say what it does and what it's for, or how they've made it. But you can also use it to deliver instructions. So in this particular project, it kind of talks you through the process of making a Maya calendar, and it does that by annotating the code. And this bit, it's like an incomplete bit of code, and there's a challenge within the code telling you to do something else. And then, so you also might use it just to add like further explanation or elaboration. So it might be that you've done your explaining bit to the pupils, but that it's helpful for them to have something that they can refer back to. And that's obviously something that's particularly relevant at the moment in the world of remote learning. It's helpful to be able to give a child a project that they can do some work on, where, as well as having had the teacher explain that work beforehand, within the project they can see like a little bit of guidance about what to do next. And that can be helpful for differentiation as well. But I don't necessarily believe that teaching and learning were the only reasons that the Scratch team who developed Scratch software, that they added the comment function in, because I think that they probably also did it because commenting on code is a really essential part of programming in any language, in any programming language, and it's so crucial to software development that like any engineer would always do it, and it's something that people get very told off for not doing enough of in the software industry. So inline documentation refers to code that sits within programming language, but that's written in a natural language. So it doesn't have a function in the program. You can see in this particular example, this is a bit of Python code, and in Python you can, if you just put the hash symbol, then it turns your text green and it stops the computer from trying to run it as code. So you can use that to annotate what's happening, and sometimes people call that hashing it out or commenting it out. So this is what that might look like in Python, and actually this is from a website called Trinket, which there's lots of different ways that you can program in Python, but if you're interested in doing a bit more of that, Trinket is a great place to start, as they have quite a few like little example projects that you can try, and it all works in a browser, so you don't need to download any software to get it working. But it's important as well to bear in mind that a lot of instances of kind of commenting shouldn't really be necessary, because if everything is kind of organized and well named and laid out in a way that's easy to read and to understand, then you might find that you don't always need to explain it. But it does obviously have advantages from the sort of teaching and learning perspective, as well as communication within a team. So I guess it's commenting in industry is really there to explain your rationale for making certain decisions about your code, or maybe to draw your colleagues' attention to something. Whereas in schools, it might be used for kind of explanation from the teacher or from the pupil. So I know that these sorts of high quality and very much industry orientated coding skills might not seem like a priority for children, but I think that if each of these practices is used, the reasons that these practices are used in industry also makes them useful for teaching and learning, because they're all really about communication, and the relationship between a teacher and a pupil is one of communication, and a two-way communication. And it's also collaborative, because children and teachers need to contribute to the learning that happens in a classroom, or a digital classroom, as the case may be. So equipping children with strategies and skills that they can use to sort of express their creativity and their understanding and their uncertainties as well, in a way where they can be clearly understood by their teacher, is really important. And it also means that when they have created a piece of work that demonstrates their understanding, they've then made something that they can use themselves, a resource that they can refer back to kind of build upon the learning that they've already achieved. So they're creating, I guess it's a little bit like good handwriting or something like that, isn't it? If you've written something, you want to be able to look back on it and understand what you wrote and what you learned, because that's going to help your learning going forward. So I hope that some of the examples that I've shown might be helpful. We've kind of, at London CLC, we've put together a few kind of remote learning based activities in Scratch, which we've tweeted out on our Twitter handle, which is at LDNCLC. And we use the hashtag Daily Scratch Challenge. So obviously these resources are very much made for educators, and so they're kind of, they're not necessarily classroom ready or ready to be sort of immediately taken to the children, but we've kind of bundled some of them up in ways that we hope might be more useful, particularly in a remote learning context. So do check out that hashtag Daily Scratch Challenge if you want to have a look at some more of those. But also if you're interested in having a look at the other little sections in this online course, then you can find that on the Tech Pathways website. And I'd also really recommend King's College London have a computer science education blog. And I actually don't think they've added anything to it for a little while, but they've still got posts on there that I've personally found really, really helpful for thinking about how I structure activities in programming. In particular, they have this approach called PRIM, which basically is breaking down an activity to predicting, running, investigating, modifying, and making. And you can kind of apply that approach to virtually any kind of like programming challenge, and come up with an activity that kind of works and takes you through that kind of process of unpicking ideas and then eventually making something yourself. I mentioned my Scratch account as well, which you can take a look at. And then there's also that Quality for Blocks website as well, which I found quite interesting and worth a little look. So I hope that's been useful. It's a little bit of a whistle-stop tour of some quite kind of big ideas, but yeah, I hope that you can see the kind of connection between some of the things that people like Marius work with, and then people like me who are kind of very much more classroom focused. But I think that the ideas that are there, they kind of follow all the way through, really. And I wish that I thought about some of these things a little bit earlier when I'd been learning to program myself.